Well, we have another question here, question 8. Question 8.1 says, given f of x equal to 3 minus 2x squared, determine f prime of x using the first principle. All right, the first principles now. I want to write the question over here, question 8.1. We have we're looking for f of x, f prime of x using the first principle, okay? While f of x itself is given by 3 minus 2x squared. Now, solving the derivative of a function by using the first principles, it's when we use when f, I'm going to give you the formula for that. F prime of x will be equal to the limit, okay, of f of x plus h minus f of x all over h, okay, h approaching 0. Now, I'm going to work out f of, I prefer to do it step by step. Let's work out f of x plus h, okay, f of x plus h. So this will be equal to, this means that wherever we have x, we're going to substitute by x plus h. So it was like 3, f of x was 3 minus 2x squared. I'm going to write like this. Instead of me writing x squared, I'm going to write x plus h. Okay, now let's simplify this. Expand first. So it's going to be like 3 minus 2, open bracket, x plus h times x plus h. That's the meaning of this part to the power of 2. Be careful here. Don't write x squared plus h squared because it's not x squared plus h squared. It must be like that. Now we're going to expand this again. We do x times x, x times h times x, h times h. So this will become 3 minus 2, open bracket, x times x makes x squared, x times h makes xh, h times x will be xh, and then h times h makes h squared. Now, this will be 3 minus 2x squared minus, okay, before I do that, let's simplify further. So we have like 2 open brackets, like terms, okay, x squared, and now we notice that xh, they can be combined because they're like terms, they make plus 2xh, and then plus h squared. Now, if I times the negative 2 to the terms within the brackets here, okay, the terms within the bracket, this will become negative 2x squared, negative 4xh, negative 2h squared. And then that's f of x plus h. Now, f of x will be equal to 3 minus 2hx squared. We can call it like equation 1 for function 1 and function 2. Now let's simplify these two functions. Simplify, why I'm saying simplifying, because I'm looking at the numerator here of this fraction. It's f of x plus h minus f of x. Now we work out f of x plus h, and then we also have f of x, which was given. We can do f of x plus h minus f of x. Now this will be, 3 minus 3 with 4, cancel, negative 2x squared minus negative 2x squared, that makes negative 2x squared plus 2x squared, and then they cancel also. And then we have left with negative 4xh minus 2h squared. And that's the difference, f of x plus h minus f of x. Okay, so we have this now. Now that we have the numerator, okay, we can divide the numerator by h. Okay, so I can do we had over here f of x plus h minus f of x. Okay, we have this, okay, equal to negative 4xh minus 2h squared. This is what we had. Now we can divide this by h and divide that also by h, because this is how the expression, okay, this is the expression of these two functions. Okay, now we can divide that. This will be like, I can take h as a common factor for the numerator, or negative h, doesn't matter. Okay, let's take negative h as a common factor, and then this will be negative 4x minus 2h. Okay, je vais more space, negative 4x minus 2h over h. Then we notice that we can simplify the h here, and then we have left with negative 4x minus 2h. Now, this is f of x plus h minus f of x over h, the expression of these parts. Okay, now we're going to introduce the limit when h approaches 0. So on the right here, if I put in the limit when h approaches 0 of what, of f of x plus h minus f of x, okay, over h, equal to, I'm gonna put the limit there also, limit of my apologies, when I put negative h out there, this is positive. Okay, it was positive, it was like that. I prefer to keep it like that, though this is not, it was not incorrect before, so I prefer to keep it like this. So that makes negative limit of negative 4x plus 2h. Now, when we say h approaches 0, it means h approaches 0 here. Yes, when we say h approaches 0, it means we can substitute the value of h by 0 there. Okay, and when we do so, we don't write the limits anymore. So it's gonna be like negative 4, negative open bracket, negative open bracket 4x plus 2. Instead of h, I want to substitute by 0, and then this is equal to negative 4x, and then that's the derivative. This is f prime from the first principle. Okay, from the first principle, h approaching 0 of f of x plus h minus f of x I don't need to write this, just want to do the derivative here. This is f prime of x from the first principle. Okay, the following question is question 8.2. Over here, the question says determine dy over dx if y equal to 12x squared plus 2x plus 1 over 6x. Okay, now move and put this way. Now, 8.2, we are looking for dy dx. Okay, and then y is given by 12x squared, 12x squared plus 2x plus 1 all over 6x. Okay, so we do know that the derivative is like the derivative function is if excuse me, the terms in the derivative, okay, given by that will be calculated as like n times a times x to the power of n minus 1. And also, it is important to note that A plus B plus C plus dot 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 plus Z over, let's say X, for instance, this is equal to A over X plus B over X plus C over X plus dot dot plus Z over X. Okay, so we can split the fraction like that. Now in this situation here, we can transform this equation or this function in order to differentiate it. Okay, it's very important. I think it's very useful to transform the function. Sometimes function doesn't come up in the way that we can easily differentiate it. So it's better to transform the fraction. I'm going to use this method to transform this fraction. You have like y equal to, so when apply that, it's going to be like 12x squared over 6x plus 2x over 6x plus 1 over 6x. Okay, so if I need I can simplify this. Simplify here by 2, and then we have like x there, we have 1, and then here also, so it'll be 3, 1, and then x gone. So this will become what? Y will be equal to 2x over 1. Okay, I don't need to write over 1, you just keep it like 2x. 2x, and then 2x over 6x, so we simplify that. This is like 1 over 3, just a constant part, plus like 1 over 6x. Okay, then there's another property. Remember law of exponent. I'm going to write the formula up here. Says like a to the negative m equal to 1 over a to the m. Okay, so in this situation, if we have like a fraction, remember those formulas are useful left to right as well as right to left. Okay, we have like 1 over a to the m, we can write a to the negative m. So we can write like, okay, because 6 here, this part only, let me just highlight it. This is like this part there is like 1 over 6 times 1 over x. Okay, only this part. So I'm going to use the law of exponent for the 1 over 6 here, 1 over x here. Then this will become, y will become 2x, okay, plus a third plus 1 over 6x to the negative 1. Now we can differentiate the function. We can work out dy dx. Okay, dy dx is the derivative of the function y. Okay, dy over dx, it means differentiate y with respect to x. So this will be like 2x derivative plus a third derivative, okay, plus 1 over 6x to the negative 1 derivative. Now remember, applying this law then, okay, or this formula, this will be, if you don't see any exponent, understand that it's 1. This will be like just 2, because 1 times 2 is going to be 2. And then x 1 minus 1, let me write everything. It's going to be like 1 times 2x to the power of 1 minus 1, okay, and then plus the derivative of all constants, okay, of any constant is just 0. So over here it's going to be 0, and then plus that's going to be then negative 1, okay, negative 1 times 1 over 6 times x to the power of what? Of negative 1 minus 1. Now this will be then 2, okay, plus 0 to 0, and then this here makes what? Negative 1 over 6, negative 1 over 6 x to the power of negative 2. So that's dy dx. Okay. And then, yeah, that's dy dx. So, okay, or someone can also transform it back into with a positive exponent. That's going to be 2 minus 1 over 6x squared. This is also correct. And then, yeah, here it is. We can now see the next question is question 8.3. Okay. Here the question says that the function x squared plus l plus b x squared plus cx minus 4 has a point of inflection at 2, 4. Calculate the value of a, b, and c. Not a, b, and c, but just b and c. Okay, fine. Let's see. I'm gonna do it over here. Okay, 8.3. So we have like the function. The given function is f of x equal to x cubed plus b x squared plus c x minus 4. Okay, and then they said it has point of inflection. You need to know that point of inflection means the second derivative. Okay, so the second derivative is the second derivative at 2. It has a second derivative at so this simply means I can write it this way: second derivative of 2 equal to 4 at the point 2, 4. Yes. Okay. Or maybe let me just write it like this, so we may not get confused here. We have another point here. 2, 4 is the point of inflection. Okay, we have the points like points 2, 4, the point of inflection, and then we're looking for the values of b, the value of b, and the value of c. Okay, how can we do that? Interesting. Okay, now as I was saying, the point of inflection is when the second derivative of the function is equal to 0. Okay, so now we have like f of x is that. Now let me find f prime of x. F prime of x will be according the formula for differentiation. Okay, this one here, we're gonna use this formula. This will be 3 times x to the power of 3 minus 1 plus 2 times b times x to the power of 2 minus 1 plus just c. Okay, and then minus 4 is going to be minus 0 now. Now the second derivative, f prime prime or f second, this will be then or maybe before I do that, let's simplify. F prime of x, this is like 3 x squared plus 2bx plus c. Okay, now the second derivative, f prime prime of x, this will be 3, this will be 2 times 3 times x to the power of 2 minus 1 plus 2b times x to the power of 1 minus 1 plus c. C is the constant. Here c is constant, is 0. The derivative of constant is 0. So this will make 6x plus 2b, and then that's the second derivative, f prime prime of x equal to that. Now it is important to note that the point of inflection means that the second derivative is equal to 0. That's the point. That's where we have the point of inflection. It's when the second derivative is equal to 0. So we're going to equate the function here to, we're going to make it equal to 0. So this makes like 6x plus 2b equal to 0. Now the question says that it has a point of inflection at the point 2, 4. It means when x is equal to 2 and then y equal to 4. So it has inflection point here when x is 2 and then y equal 4. Now when I substitute the value, when I sub the point of inflection here, let's sub inflection point. Okay, let's do it. Let's do it next. This side. Over here, we can just say sub the point to 4. Okay, so the function will be like this is the second. It's going to be like 6 x plus 2b. 2b equal to 0. If I sub the point of x, which is 2, the value of x, which is 2, this will be like 12 plus 2b equal to 0. Now, if I move the 12 over, that makes 2b equal to negative 12, and then we can solve for b if I divide both sides by 2. If I divide here by 2 and then divide by 2, we'll get like b equal to negative 6. So we got b. So if we had b, we can substitute the value of b in the main function, okay, in this function here. So the function has now one unknown less. So it's going to be like f of x equal to x cubed plus, not plus, but minus 6, because that's the value of b, x squared plus cx minus 4. Now, the point of inflection is the inflection of the line, of the curve, okay? So this is going to be part of this point will satisfy the equation of this line, okay, of this curve. So it means when f of x is the same thing as y, so if I sub here 4, and then I'll sub wherever cx by 2, okay? Plus cx minus 4. I'll sub here by 2, okay? 2, and 2 there. Now this makes that 4. We can use a calculator for this, or maybe we cannot. This is 8 minus 4 times 6, negative 24, plus 2c minus 4. And then this makes 4 equal to, we can reduce this, 8 minus 24 is negative 16. Negative 16 minus 4 is negative 20. So this makes like negative 20 plus 2c. So if I move the negative 20 over, that makes, let's just do it here. Negative 20 over, or maybe I should, yeah, I can just do it here. That makes 24 equal to 2c, and if I divide both sides by 2, and then we get c equal to 12. So this is the value of b and c. Thank you.